Good morning. So today, inshallah, will be a review for all covered material for the midterm. So if you have any part unclear in all what we studied, so please let me know. We can revise it. Okay. Anything unclear in what we studied? Okay. So let's take some exercises and to see the type of questions that can be asked in the midterm. Also refresh your mind about all previous chapter 3, 4, 5, and 11. So the first question, broadband transmission of digital signal is possible only if we have broadband transmission. We studied two types of transmissions, baseband and broadband. What's the difference between broadband and baseband? Yes, so we send in low frequency or low bus channel, and the broadband we can send in higher frequency or baseband baseband channel. So these are two types of transmission of digital signal. Baseband, we can send a low bus channel, low frequency, and broadband transmission, we use band pass channel or higher frequency. Okay, so broadband transmission is possible only if we have a band pass channel. If we have low bus channel, we can transmit using broadband. We will use baseband. But if we have band pass channel, we can use broadband transmission. Okay. This is directly from the slides. Okay. What distinguish unipolar technique from other line coding techniques? What's unique in unipolar? Hmm. Or in another type, what's the difference between the unipolar and the bipolar? Exactly. So in unipolar, we send the data in one side of the axis. In zero, so the signal can take zero or positive voltage. So one take positive voltage and the zero takes zero voltage. So unipolar we send in one side. The bipolar we can send in two sides, in positive and negative. Okay, and this is طبعا summary of the different line coding techniques, what supports synchronization, what not, and bandwidth, and so on. So these two slides is important. So what distinguishes unipolar technique from other line coding techniques? They use positive and zero voltage. Okay, this distinguish any unipolar techniques. Okay, so unipolar use positive and zero voltage. The bipolar, for example, will polar using positive and negative voltage. Okay, which of the following encoding method doesn't provide synchronization? Hmm. Exactly, yes. Mountain to zero link. Because return to zero can support partially synchronization and also inversion can support partial synchronization, but non-return to zero L doesn't support synchronization. Is normally referred to as MPNP coding, and it replaces M bits by N bits. Flow coding. Yes, exactly. Provides synchronization without increasing the number of bits. Yes, exactly. Scrambling. So as we said in scrambling, it doesn't change the bit rate. And also remove the DC component. So it supports synchronization, remove the DC component without increasing the bit rate or without increasing the number of bits. Because we change n bits by another n bits. We change 4 bits by 4 bits, 8 bits by 8 bits. So we don't increase the number of bits. Okay? in which encoding the duration bit is divided into two halves. The voltage remains at one half during the first half and moves to another level in the second half, with transition at the middle provides synchronization. Which of these techniques provides synchronization and make inversion in the middle of the bit? Yes, so both of them. Okay, I uploaded the slides without answers. عشان who attend can see the answers. Okay, substitute four consecutive zeros with 00V or B00V. Hmm. Who substitute the four consecutive zeros with the code. Now, the B8 0F 0S change in 8 zeros. 8 zeros. So A HDB3. Okay. A digital signal includes timing information in the data being transmitted. Self-synchronization. Include timing information to support synchronization. Okay. What is the advantage of an AMI over a non-return to zero I? Exactly. This component is resolved. Why? Because in AMI, zero remain at zero, return to zero I. Can in one make inversion, but the zero can remain the same. So if we have long zeros and the previous one was positive, so long zeros will give this component. But in AMI, long zeros will be always zero, and the one will be always inversion. So will not have this component. Okay. The advantage of 2B 1Q over non-returns to 0L. Hmm. What is the value of R for non-return to 0L? R number of bits per number of signal level. Non-return to 0L. R equal to what? 1. And 2B 1Q. What's the value of R? هو 2B 1Q أصلا إيه؟ multi level. Multi level encoding. ف from the name 2B, two binary bits in one signal element. So R equal to 2. So non-return to 0L or I, both of them الباندويثs equal n over 2 لأن ال R equal to 1. ال S equal n over 2 while البولر مثلا for example return to 0 كان ال N ال S equal to n لأن ال R but المالتي ليفل 2B1Q كانت البود ريت or bandwidth or S equal to n over 4 لأن ال R كانت equal to 2 we send 2 bits equal 2 so the bandwidth equal n over 4 so the advantage of 2B1Q less bandwidth. Okay? We increase the number of bits in the same signal element so it has less bandwidth. Okay, it's important from all types of these questions to know the difference in bandwidths between the different line coding techniques and who supports synchronization, who remove a DC component, and so on. Yes. Then S كانت half n over r. If you remember bandwidths for this لا ده wrong يعني. Explode equal to. Okay. for 8p60 signal with data rate 400 kilobit per second has a minimum bandwidth of when c equal to 1. What's the bandwidth؟ هو اللي هو اهو ان الباندويث the bandwidth given data rate 400. Only the R. What's the R for 8p60? Yes, from the definition, 8 bits in 6 signal level. So R equal 8 over 6, and we have it in 4K, 400K. So the bandwidth will be 300 kilohertz. And 400K multiplied by R will R 8 over 6. So you can calculate the minimum bandwidth 300K. Okay, with data rate in kilobit per second, so bandwidth in kilohertz. Okay. What is the advantage of scrambling over block coding? Replaced by code. But both of them, and both of block coding and the scrambling, remove DC effects by replacing some bits with another code. And both of them remove the DC component and make synchronization by exchanging the bits. But what's the difference between scrambling and the block coding? يعني both of them خلاص remove synchronization. Yes, exactly. The block coding we replace each n bits by n bits. So I increasing number of bits. But in scrambling, I change 8 zeros with 8 bits or 4 zeros with another 4 bits. Okay? So again, the scrambling remove bit rate. Okay? So المفروض السكرامبلينج والبلوك كودينج is very easy يعني والكونسبت بتاعتهم very easy. حرام تلوز كريدتس في كويشنز فيها سكرامبلينج وبلوك كودينج. Okay? السكرامبلينج over block coding has less overhead. Okay? Signal blue most likely uses scrambling scheme. فاكرين السؤال ده؟ from the quiz. السؤال ده كان في كويز. بسيط terminal. Why بقى؟ لأن from the figure الزيرو الزيرو always make inversion يعني sometimes take positive sometimes take negative فالزيرو make inversion والone always zero فهو make الone always zero والزيرو make inversion البسيطو terminal. Okay, so you can detect type of the coding from the figure by checking the value of one and zeros will be fixed. One will always take fixed value, zero will always take fixed value, or one with zero make inversion, and which take fixed value, which make inversion. Okay, فالبسود terminal one equal zero all the time, zero make inversion. Okay, signal blue most likely uses line coding technique or scrambling technique. يعني الفيجر ده كان اصعب من اللي فات بس انا حطيت لكم الاسهل كويس برضه غلطتوا فيه. ده which type of coding؟ ما ماشي 8 zeros. ما 8 zeros يبقى احنا we change ال 8 zero by different things يعني 8 zeros have different code فاحنا في انهي كاتيجوري؟ من which category؟ scrambling. طب دلوقتي بقى السؤال scrambling عندنا two type of scrambling B8 ZS وفي HDB3 ف which one؟ if you check هتلاقوا ان ال 4 zeros the first 4 zeros have different code from second 4 zeros. It means ان انا I'm using two codes 00B و B00B. It means in the HTTP3. اوكي. ال بي بي 8 زد اس كان ديفرنت كود 000 في 0 بي حاجه كده، فكان ديفرنت كود. فهي if you check the code you can define الزيروز والفي والبي it will be two different codes for each four consecutive zeros. ده اتش دي بي 3. اوكي clear. Any question? Okay. This for revision يعني plot the digital encoding for this sequence of bits. فلو unipolar اليونيبولار ال 1 always positive ال 0 always 0. This is simplest one. البولار ال 1 positive ال 0 negative. ال non return to 0 invert. ال 1 make inversion with 0 makes the same. So I start with my 0 equal to 0 وال 1 make inverse Manchester والديفرنشال مانشستر. And you can use this slice to revise all type of encoding يعني to practice after يعني after studying you can practice on this example to generate ال digital encoding. Yes. differential. طبعا ممكن اشرحه لك من السلايدز اسهل. يعني مانشستر So what you need to define is the start of the bit. Then the middle in the middle you will make return to zero because it's Manchester or differential Manchester. Both of them make return to zero in the middle. But in differential Manchester, is zero make inversion, L1 doesn't make conversion. Okay. Which of the following technique is used to change the digital signal into varying phase for broadband transmission? Who changes the phase for broadband transmission? Which technique change the phase? Phase shift key. في another one. PM. Phase modulation. But one from digital to analog, one from analog to analog. Both of them change phase. Okay. فaccording to the يعني multiple choices you can define. فالمالتيبل choice كان الباينري phase shift key. والباينري shift key change the phase for broadband transmission from digital to analog. الفيس modulation change الفيس also but from analog to analog. Okay. two type of techniques change الفيز. طب which of the following technique has the lowest bit error rate? And I get bored from repeating this question. Which has the best error rate? Which has the less bandwidth? And I put this question in the quiz to take all of you the grade. بس اتفاجئت ان هو كان من اصعب الاسئله ما اعرفش ليه. يعني this is what we studied before. 4 كوان differentiate to 16 1 for example. الباينري بيس كي طبعا يبقى only 2 bits. As we increase the number of points, we increase bandwidth. We decrease the bandwidth because we put more data in the same bandwidth. So we can send the same bit error rate in less bandwidth or increase the data rate in the same bandwidth. So I am increasing the bits. But on the contrary, can I differentiate easily between these bits? No. الإيرور increase. في المقابل الباينري بي سكيل only 2 points. فالداتا ريت high or low لأن two symbols. So data rate low. Can I easily differentiate between these 2 points? Yes, but I only have 2 points. Cube scale than 4 points. Which is better? Differentiate between 2 points or differentiate between 4 points? 2 points. I mean, has less low has lowest error and only 2 bits. But who has high data rates? USK ولا binary SK? USK and USK الR فدونت get confused between والerror. الداتا rates who has large R multiple points. The same data rate. But the error is increasing the number of points or increasing the order of the modulation, the error always increase. اوكي فاللي طبعا عنده lowest bit error rates الباينري بي اس كي but اللي عنده highest data rates 16 QAM or 32 QAM or so on. So with increasing the order, I'm increasing the data rates, I'm consuming less bandwidth, but I increase also the error. So please يعني don't get confused with this question again in the midterm. تبقى مشكلة يعني ما انتم مصممين بقى. Okay. ال AM and FM are examples of analog to analog modulation or analog to analog conversion. وال AM طبعا هو changing الامبليتيود وال FM changing الفيز. Changing frequency, yes. Analog to analog conversion is needed if the available bandwidth bandpass. So I'm using analog to analog to shift my data in high frequency or in bandpass channel. Which of the following not digital to analog conversion? AM. And take care about not. Okay. Then don't see digital to analog, for another one. Not digital to analog. Okay. If the bit rate for ASK is 100, 1200 bit per second, what's the boot rate? هو ليه علاقة بين البود ريت وايه؟ والبيت ريت وايه العلاقة بينهم؟ العلاقة بينهم هي الار وممكن يبقى في كونستانت هنا سي اور تي اور something يعني according to the formula. but المين كومبوننت هو الار. طيب الاس كي الار منها ايه؟ الاس كي هو ايه؟ what's the r؟ and I'm changing the amplitude r equal to 1. لما r equal to 1 it means bit rate. So if the 1200 فالبود ريت هيبقى 1200 هو كمان. اوكي. طيب في 16 كوام بقى الموضوع مختلف. If the bit rate for 16 كوام is 4000 bit per second, what is the boot rate? Again العلاقة بينهم هي ال R. طب ال R for 16 كوام 4 لأن ال R log 2 L وال L symbol and correlation diagram all this L. So log 2 16 is 4. So sending 4 bits in one symbol. The relation between البوت ريت والبيت ريت هيبقى البيت ريت divided by 4. يعني each 4 bits sending in one symbol in one boot. فلو هسند 4000 bit it means I will send only 1000 boot لأن each 4 represented by 1. Okay. ف this type of question برضه easy. العلاقة بين relation between البيت rate والبوت rate is very easy. What you need to find only ال R. وتسبستيتيوت direct في الفورمولا. You should بس define ال R for different type of modulations طبعا. طبعا for ASK BSK كل ده R equal to 1 QBSK ال R equal to 2 QBSK QBSK we have 4 points mean L equal 4 but ال R log 2 4 يبقى 2 QBSK 2 ال 4 كوام 4 32 كوام 5 and so on. Given an AM radio signal with bandwidth 10 kilohertz and the highest frequency 705 kilohertz, what's the frequency of the carrier signal? What's the frequency of the carrier signal? هو ال AM modulation أصلا is analog to analog فالباندويث بتبقى في الهاي frequency. الكارير frequency where we put the carrier frequency in the middle of the bandwidth. فدايما الكارير frequency in the middle of the bandwidth والباندويث 10 كيلو هرتز والهايست 705 يبقى اللوست كام؟ ده هنقسمها يبقى 5 هنا 5 هنا يبقى هتبقى 700 بحيث تبقى الباندويث كلها لا لا ثواني لا I am asking about the carrier sorry فده 700 ده 795 but the carrier frequency 700 because I'm asking about the carrier frequency. Okay. Okay. يعني this question mainly need to know the carrier frequency in the middle of the bandwidth. Okay. For a channel with maximum bandwidth 4 megahertz using FSK frequency shift key to send 2 bits at a time. What we mean to send 2 bits at a time? يبقى ال R equal to 2. Okay. والباندويث 4 ميجا وأنا using FSK with G equal to 1. What's the maximum data rate? والماكسيمم data rate I'm asking in megabit per second. Okay. فتيك كير ان انت don't calculate it in كيلو مثلا or in bit per second. فال FSK كان الفورمولا bandwidth equal 1 plus DS البود ريت plus L minus 1 number of levels في 2 دلتا F. واحنا قلنا 2 دلتا F equal to S. المينيمم value of 2 دلتا F is equal to S. فلو 2 دلتا F not given you will consider it equal to S. Okay. طيب والنمبر of levels here what's the number of levels in this question 4 يعني we need to send 2 bits at the same time it means r equal to 2 يبقى ال L equal to 4 2 to the power r يبقى ال L equal to 4 وال G equal to 1 it means I will have 2s plus 3s يبقى 5s والباندويث 4 ميجا ف 4 ميجا على 5 هتلاقوها انها 1.6 ميجا بت بير سكند اوكي you just can substitute direct in the formula except in 2 delta f equal to s because the minimum value of 2 delta f you have to know that the minimum value of 2 delta f if it's not given it's s الاس اللي هو البود ريت طبعا اوكي the bandwidth for phase modulation signal to modulate 5 kilohertz signal is in kilohertz when البيتا equal to 2 الفيز موديليشن كان الباندويث بتاعته 2 1 plus beta multiplied by b b the bandwidth of the original signal b هنا كام what the b 5 كيلو هرتز I need to modulate 5 كيلو هرتز voice يبقى البي equal to 5 كيلو هرتز البيتا equal to 2 so the bandwidth will be 2 plus 1 3 3 multiplied by 2 6 6 multiplied by 5 ب 30 كيلو هرتز الاوريجينال بالكيلو هرتز فالباندويث also بالكيلو هرتز also direct substitution in the formula but you should know ان this formula for الفيز موديليشن الانالوج تو انالوج موديليشن والبريفيوس فورمولا كانت for shift key or digital to analog conversion ف you have to differentiate between the bandwidth of digital to analog والانالوج to analog okay this for analog to analog والprevious one كانت digital to analog substitute in correct formula يعني الفورمولا هتبقى given في الامتحان في الاكزام all formulas will be given but you have to define طبعا which formula to be used okay chapter 11 بقى define the framing and reason for its need what's the framing and why we need framing you will be asked questions like this in the midterm بقى هيبقى one question multiple choices with two other questions written okay فdefine framing and reason for using it why we need framing الفريمنج هو dividing المسج into smaller bits or small frames so framing we need to divide the long message into blocks of bits يعني or frames of bits طب why we need frames to support flow control and error control so instead of sending the whole message as a one block or as a one file the receiver may be overwhelmed or overflow so I can send piece by piece so the receiver can receive them correctly and decode them correctly so I can support flow control and error control using the frames so the framing is a process of dividing the message into smaller pieces or smaller entities and we use frames to support flow control and error control okay we discussed طبعا في in the class what's the advantage and disadvantage of sending long frames or small frames we send very long frame but have some error I will lose a lot of data but also if I send very small frames I will consume the bandwidth unnecessary يعني I will send many small frames so I will send less data in this case then each frame has overhead has IP address and so on so if I increase number of frames I will increase the overhead but at the same time if I increase the frame length and get an error I will also lose a lot of data compare between the byte stuffing and the bit stuffing and which technique used the byte stuffing which using the bit stuffing البايت ستافنج والبيت ستافنج اللي we used يعني البايت ستافنج مع مين which type of framing character oriented والبيت ستافنج كان مع البيت oriented اوكي فالكاركتر oriented بروتوكول كان بيستخدم بايت ستافنج والبايت ستافنج can fixed character or fixed pattern, 8 bits or character, to differentiate between the flag and the normal data, because I am putting flag at the beginning of each frame. So if the flag is repeated in the data, I have to put before it skip to let the receiver know skip this part. It's part of the data, not part of from the flag. The same for bit stuffing, but with bit-oriented protocol. In this case, if I have 4 consecutive zeros, I, I will add extra zero to differentiate between the consecutive ones inside the data or the consecutive ones in the flag. Okay, for each 5 ones, I am increasing 1 bit of zero. This is bit stuffing. So this example of bit stuffing, if I give you this code and I tell you to use bit stuffing, how many zeros you will add? How many extra zeros you will add? البيت stuffing each 5 consecutive each 5 consecutive five. So in this case, for this example, we will add 5 zeros. Okay, this is a bit stuffing. Another example, طبعا if assuming الفلاج 610 فده fixed flag, we don't need to repeat this in the data, so we avoid this by adding 0 after each 5 ones. This is the data. Again, after each 5 consecutive ones, I add extra 0. Okay, so this is the answer after adding the zeros. Okay, any question? Okay, in which protocol we use which stuffing techniques? Hmm. كاركتر اورينتد مع بايت ستافنج، لان الكاركتر اورينتد مش مع البيت والبيت مش مع الكاركتر. هو الكاركتر اورينتد بيبقى مع البايت والبيت اورينتد بيبقى مع البيت ستافنج. اوكي، فالانسر will be C، character oriented مع البايت stuffing. Okay, data link control deal with the design and procedure for node to node communication. طب مين اللي process to process؟ physical برضه node to node، يعني في الاخر two nodes I need to transmit the data between two nodes. transport layer هي اللي process to process. طب مين الهوست تو هوست؟ الابلكيشن هي process to process، you need to run certain process and you need to run another process. الابلكيشن or الترانسبورت layer deal with the process level، يعني الهاير بقى application level or process layer. النتورك هي اللي هوست تو هوست، لان في الاي بي وفي راوتنج في النص، فالنتورك هوست تو هوست. but النود تو نود without بقى any routing without anything دي الداتا لينك layer والفيزيكال layer. in data link layer separate the message from one source destination or from the same source. مين اللي ميك separation للمسج or dividing المسج؟ الفريمنج. stop and wait automatic repeat request special case of go back in when the size is. ده كان في السلايد وانا هايلايتد في السلايدز ان جاء في الميد تيرم السنه اللي فاتت. امتى الستوب اند ويت بيبقى سبيشال كيس من جو باك ان؟ when size 1 when I am sending only one frame، فالستوب اند ويت بيسند one frame and wait. الجو باك ان I can send any frames. So it's special case when send window size is 1. In which protocol the sender send one frame and stop until it receive confirmation؟ stop and wait فقط، مش stop and wait automatic wait request، لأن stop and wait automatic wait request has timeout. So I am waiting for acknowledgement or timeout. أما اللي wait for the acknowledgement only هو ال stop and wait. Take care. Okay. In which protocol we avoid unnecessary transmission by sending only the frame corrupted؟ selective repeat بيسند only corrupted frame. طب الجو باك ان كان بيريسند all window. If I lost only one frame I sent all window. And data link layer is based on automatic repeat request which is retransmission. Who support automatic repeat request or retransmission? الايرور كنترول هو اللي بيعمل retransmission. الفلو I need to wait for acknowledgement until the receiver finishing the processing. So sending acknowledgement, so I resend the frame. So this flow control. But the error control, I make retransmission to correct the error. For stop and wait automatic repeat request for 10 data packets sent, how many acknowledgement I need? If I send 10 frames or 10 packets, how many acknowledgement I'm waiting? أو في جو باك ان لا هو less than 10 مش شرط بقى ممكن I receive 10 عادي but not mandatory. I can receive less than 10 لأن any one for example if I lost for 1 and 2 by receive 3 it will account for the 3 but in stop and wait each frame I have to receive acknowledgement exactly 10 go back in with selective repeat less than 10 okay and go back in if the window size is 63 what is the range of the sequence number السؤال ده حلو كنت عايز احطه في الميد ترم لقيته موجود في الريفيو the window size is 63 هو اصلا لو الويندو سايز 63 يبقى الام ايكوال تو وات؟ لا الام 63 ده النمبر الويندو سايز الام اللي هي النمبر بيتس نمبر اوف بيتس هو لوج 2 هو لوج 2 كده 64 طبعا عشان يبقى كونستنت نمبر فالام هتبقى 6 لان في الام 6 I have range يعني الام ده نمبر اوف بيتس but 64 ده الرينج طيب if the window size is 63 يبقى الرينج of the frames ولا from 1 to 64 ولا from 0 to 64 why بس الام عندنا 6 it takes 64 لان الجو باك ان كان الويندو سايز اصلا كام؟ هو ام minus 1 الرينج من 0 ل 63 يعني كده I have 64 numbers but the window size 63 لان في minus 1 في الويندو سايز ف if I have sequence range 64 الويندو سايز هتبقى 63 لان هتكون باور ام minus 1 where can we use الباندويث delay product والباندويث delay product هو number of bits to fill the link okay ف when we used الباندويث delay product في اللينك utilization I need to account for efficiency of utilizing the link or percentage of utilizing the link I have to use the bandwidth delay product then I see how many bits I send from this utilization bit can fill the link but I can send one frame or any frame according to the technique I am using so I am sending part of this but the maximum utilization percentage is bandwidth delay product so this is important I'll calculate the utilization of the link بالباندوث delay product okay how many extra bits فده سهل you will add h5 ones هتadd 0 what's the difference between stop and wait automatic repeat request التايمر فالستوب اند ويت automatic repeat request add error control الايرور كنترول هو التايمر والريترانسميشن stop and wait ما بيعملش retransmission what's the difference between go back in and selective repeat الجو باك ان الويندو سايز طبعا مختلف التايمر when expire sending all the frame and give copy of all the frames والترانسميشن all the frames والويندو سايز مختلف okay I take care of both these questions this if you ask you about shows timing diagram of transmitting 3 bits with acknowledgement. We have to answer it like this. You have to make it again. Make shifting. By the time now, make it transmission. That's the one way. Very important to know how to plot time diagram. Okay. لو غلطتوا فيه بقى انا مش مسؤول. يس. في سؤال قبله بس انا عشان اسيبه الاخر عشان الوقت قرب يخلص عشان السؤال ده مهم برضه. اوفر اللي عندي to have link you have stop and wait. I'm choosing one frame and wait for acknowledgement. This stop and back automatic bit request. الباندويث 2 ميجا بت per second and each frame 2000 bit and I need to send and each a round trip 20 milliseconds. Okay, and I need to send 2 million bits. All frame and acknowledgement received correctly. What's the time to send 2 million bits? Mhm. I need to send 2 million bits. Let's stop and wait. What I have to wait to send 2 million bits? I have to make transmission, so I have to upload the data, then propagation delay. So I have transmission delay and propagation delay. Propagation delay or round trip لأن I sending frame and wait for acknowledgement. So propagation delay هيبقى equal to round trip. So I need to calculate transmission delay and propagation delay and number of frames لأن now each frame 2000 bits but I need to send 2 million bits. يبقى how many frames? 1000 frame لأن I need to send 2 million اللي هو 2 to the power 6 2 10 to the power 6 على 2000 so I need to send 1000 frame. Each frame I take number of bits transition time for each وده جيب على طول محتاجين تحسبوه هو البروباجيشن ديلي طبعا بيساوي الديستنس على will take time to send 2 million bits. Okay, this is important how to calculate transmission time, propagation time or round trip, and number of frames to calculate the total time. Okay, this is this and this very important example. Okay, some of you asked about the formula sheet. This will be the formula sheet in the midterm. Okay. Any question? مسائل وحاجات زي مثلا what's the framing, what's the difference between stop and wait, what's the difference between go back in and selective repeat وبعضهم هيبقى مسائل. Okay. Okay, thank you.